Hello, hello, hello. Hey. I'm not hearing anyone yet. Okay, I hear someone. Simone. It must be you.
Hi.
Hi. Give me 1 second. My baby's sleeping and I do not want him to wake up right now. Okay. Here we are. Hi. Welcome to our study session. I'm here. Any questions?
Okay.
Getting my questions organized.
Okay. Let me get my mouse. All right, Tara, I'm here. And
All right.
whoever else has questions.
Well,
how's everybody doing, first of all? Everybody good?
Good.
Hope you're not stressed out by this class, by COVID, by life in general.
A little bit.
Yeah. I am too, actually. I'm praying that God would just release some of the stress because there's a lot going on right now.
Yeah,
it's
a lot. It is a lot.
So if I could help in any way to alleviate some of that, I can't take away the exam, but I can help you pass it. So let's go. Let's get going.
Okay. Can I go?
Sure.
Okay, so my biggest challenge right now are the interpretations. I think that's what I'm having most of my difficulty with, particularly with the last few lessons, I would say from lesson 7 to 9. So if you're able to go over how to do the interpretations in a way that it will be graded correctly, not if you understand what I'm saying, that, you know, it would make the grade. So like interpreting the T-stat, the P, you know, the ranges, in the population versus in the sample, keeping the constant, stuff like that. That's my only question. Yeah.
Real quick, Professor, is this being recorded? Are you going to send this out, or do we hit record if we have to review it later?
Are you recording?
I just see it saying recording at the top. I didn't know.
Yeah, I didn't know it was being recorded. I literally just saw it as you said it.
Okay.
Maybe you have set up automatically.
Oh, maybe I set it up that way. I didn't know.
Mm-hmm.
So you want it recorded or you don't want it to be recorded?
No, I don't care. I don't care.
Okay.
I
So
just
since
didn't
it
know if
is
it was
being
going to be.
recorded,
No,
I need to find out where it's being recorded to so other people can see it. I actually have recordings from previous semesters when we were not in COVID pandemic mode, where so like we were in the classroom, people were asking questions and it's back and forth. So that's also on YouTube. If you watch any of my videos, I'm sure at least two of them might be up on there.
Okay, cool.
But yeah. Yeah, so this is being recorded, so I'll try to find where it is and share it.
Okay.
All right, cool.
Okay.
All right,
anything else before I pull up what I was about to pull up for us to view? Can you guys see the screen?
Yes.
Okay, so the first question, oh please, I may have to call my husband because okay, give me one.
Sweet baby.
Yeah, he did not sleep that long.
Aww.
So I wanted us to I don't think he woke up. Pico, biawe wanta Pico. I'm na class. Statistics. Okay. Okay, so everybody knows how to do the equation, yes?
Yes.
Okay. Am I getting yeses all around?
Yes.
Okay. So we know how to get the equations. We know what y-intercept. We know what. Hold on, my husband. Okay. So, hey Gerard, hey Steven,
Hello.
hey Jessica. You guys just came in.
Hi. How y'all doing?
Okay, so y-intercept. Somebody tell me what that, let me scoot out of there. Y-intercept. Which of these is the y-intercept? Which of these is the y-intercept?
The y-intercept is BO.
B not, right? What is this B1 called?
The regression.
The
Regression coefficient?
independent variable.
No. The B1 is the regression coefficient, and X is your independent variable. Yeah?
Yes.
Y is what? Anybody? Y is?
The dependent variable.
There you go. Okay,
right.
So if we know how to come up with this equation, we know the names of all these things. So then, as long as we know that first, if we don't know that, then my questions afterwards don't have any meaning. So if I say what is B naught or what is y-intercept, you are able to look at the equation and say that one, that's y-intercept. Or you are able to look at the output here and know which one of these is the y-intercept, right? Which one is the y-intercept? Which number here?
The constant.
Negative.
Yeah.
Yes, constant.
Negative
5,000, right? Okay.
Yes.
So with that, let us now read through the slides that are here to help you know how to do this interpretation, Miss Simone. Okay?
Yes.
So B naught,
Thank you.
yes, we know it's the y-intercept. B naught is the expected value when y of y when x equals 0. So here we have this output with this equation, this output, whichever one you want to look at. And I'm asking you, what is y-intercept? You go, oh, it's negative $5,132.76. And I say, well, okay, great. I'm glad you know what it is, but what does it mean? Okay. If you, for starters, right, just literally write this part out, that is the correct answer. And what do I mean by that? You write B naught. What is B naught here? Negative
$5,132.
Is the expected value of what is y in this situation?
479.
What is y? I didn't hear.
Dependent.
No, what is it? And this is, I'm glad that you did that. I'm glad that you did that because I know I've been taking off partial points here because people say the dependent variable or they say y. So if I know that your name is Tara or Blair or Simone, I'm not going to say you over there. I'm not going to say student X. I'm not going to say that chick, right? I know your name. I'm not going to disrespect you like that. I'm going to call you your name. Okay, so think of it in that way. Okay. I know some of you are like, oh yes, I totally get that because I got half a point for that.
Yeah, I did. So, now I know what I'm doing wrong.
Yes. So if you know the name, say the name. And in this case, we know why. We know why because it says we know y is the dependent variable, and it says the dependent variable is what? Salary.
Salary in dollars. Yeah.
Right. So salary. So again, let's start from the beginning. Negative $5,132 is the expected salary, right? Somebody complete the rest for me. When
grade equals 0.
Thank you. Who said it?
Me.
Okay, me. Thank you, me.
You're right.
Okay. So are we good? So far.
Yes.
Yeah? So all we did was say, all right, Dr. Chuku provided the second line here. I'm just going to say whatever. I'm just going to substitute these words for what I know is X, what I know is Y, what I know is B naught. So B naught, negative 5,000, is the expected value of Y, is the expected salary if I have a grade of 0. Guess what? If we go down to the first bullet, down here, the black bullets, it tells us the y-intercept tells us that the expected salary for employees at grade 0 is that. But bullet 2 says there is no such thing as a grade 0, right? The lowest grade in salary for federal government is a 3. So this grade 0, this negative 5,000, this I'm paying the government $5,132 just to be working for them has absolutely no meaning. It's a baseline for a predictive model. It's a baseline for this equation that we're going to use to predict other things that are actually meaningful. Okay? So that's what all these words here are saying, okay? So we have this awesome equation, and then we can go over to where we're doing our predictions. I've skipped some things because we'll come back to it. But here, I want to get to the point where at the very beginning of these slides, I said that regressions are used to make predictions. The whole name of this game is I have a dependent variable. I need to be able to predict it. Or I have an independent variable and the dependent variable. Let me see if I change this, what'll happen with this. If I change that, what will happen with this. This is all about predictions, okay? So I start off that way, and then we talk about how to do those predictions, And then voila, here we are. So we have this equation that we've been working with. Then we plug in, all right, well, what should I expect my salary to be at grade 4? So you put grade 4 in here. That's what you should expect your salary to be. Pretty terrible. For I think this was 1998 data, but that's still, I mean, poverty level. Salary at grade 7, salary at grade 11, right? And we know that the GS scale, right, is a scale. So this might be the low end of it or the midpoint of it, right? But these scales, this general, what is it called?
General scale.
Is that what it is? GS, yes, GS. These GS levels, general scale levels, takes you from, so this might be grade 11 might be from 45 to 85, and that's a range, right? But it's saying on average you could expect your salary at grade 11 to be 47,000. Are we understanding like the gist of what this regression thing is supposed to do now? Yeah.
Yes.
Okay. So we got what y-intercept is. Yes. And now we go to the regression coefficient, B1. And we know that in the next lecture, this is lecture 6, where we just had a bivariate regression. Bi meaning 2, 1 dependent, 1 independent, 2. Bi. All right. Then we go to lecture 7, where it's a multivariate or multiple variables, right? So still, how many dependent variables?
1.
Only 1. In this class, you were not going to learn all that other complex stuff. Just 1 dependent variable and more than 1 independent variable. Okay. And so in this case, we just have 1 independent variable, and that independent variable in this slide is
grade.
So we know B1 is the regression coefficient. Awesome. Great. This bullet number 2, famous for where I put the interpretation, right? Bullet number 2 tells us that the regression coefficient is the expected change in Y for a 1-unit increase in X. Regressions are predictive models for a 1-unit increase in X in your independent variable. You can't just say as it increases. No, it has to increase by 1. You can't say, oh, as it increases by 10. No, it has to increase by 1. Okay, that's just the math of it. That's just how it is. Okay,
so that's why it's always increases by 1, and then it's like, then it can be increase or decrease depending on whether or not it's a positive or negative number.
Negative.
Yep.
Oh my God. Okay.
Okay, so as it increases by 1, then we look at our regression coefficient. What is our regression coefficient telling us here? What is that number we should be looking at?
B1, which is 4779.
Yes, $4,779.04.
Because it's the independent variable.
Huh?
Yes.
Okay, everybody's saying yes, but I didn't hear it.
Okay. I think I was mumbling to myself, and I said it's the independent variable.
No, 4779 is not the independent variable, right? 4779 is the Gerard is up. I saw you mouthing it, but yes, is the regression coefficient.
Regression coefficient. Okay. I'm looking on my phone, and I'm like, oh God, I think I have to put on my glasses.
So the regression coefficient 4779 for the independent variable grade, and then we're just gonna plug and chug. So bullet 2 tells us that $4,779 is the expected change in your salary, right? And we know it's not just a change. We know it's an increase, right? Because it's not a negative sign. But if it was a negative sign, we would say decrease, right? So is the expected increase for salary, in salary, for a 1 unit increase in grade. So if we look down at my interpretations below, of course they're saying the same thing, but you could say it other ways, but right, but it all means the same thing. As pay grade increases by 1, say from 11 to 12, from 7 to 8, right, from 3 to 4, as it increases by 1, the person's salary should increase by almost $5,000.
Okay.
Okay.
So just for clarification.
Yes.
Are you saying that grade is X, but the actual number 4779 is the regression coefficient?
Yes.
Because to me, they're one and the same, but you're saying that it's different.
Why would you say it's one and the same?
Because when you look at the you know, just the way it's laid out, when you look at the, what do you call it? The box or whatever, grade looks like it's equal to 4779. But for the first time, I'm understanding that the regression coefficient is the number, but the independent variable itself is called grade. Am I correct?
Yes.
Okay, thank you.
Yes. Okay.
I can get that sometimes, but not other times, Simone. So I feel you.
Oh.
This is very helpful.
Okay, good. So now this is essentially all that we did with lecture 6. We figured out what how to do the equation. We figured out all the elements of the equation, what x means, and it's a dependent variable, the independent variable, what y means, and it's the dependent variable, what b naught is, intercept, what b1 is, regression coefficient. And from there, we took it up a notch to lecture 7, where we do literally everything the same, but now we have more x's. And Miss Simone now knows that all of these are what?
Independent variables.
Yes. And all of these are anybody.
Regression
Coefficients.
Right.
Okay.
Okay.
So,
Okay.
and this always tells us what the dependent variable is. We never have to guess, right? We got our dependent variable. We have all of our independent variables. We have our regression coefficients, and we have our y-intercept, the constant. Okay.
Right.
So the difference between lecture 6 and lecture 7 is holding things constant.
Constant.
Okay. So we go into a room. Let me just talk about my background. You can't go into a room and just there's a whole bunch of people in there, and you say hi to one person and nobody else. You got your aunties and uncles in there, you got your cousins, you got everybody in there, and you just go straight to one aunt and be like, "Hey, auntie." No, in the Nigerian culture, you have made a big boo-boo. Okay, you might have thought nothing of it, but it's a big deal. Okay, so we acknowledge everybody. Okay, you might go straight and talk to one person at the end of it all, but you need to acknowledge everyone in the room. And so I say that, I preface that, but in order to say that that's what lecture 7 is all about. That's the only difference between lecture 6 and lecture 7. In lecture 7, you might go in and say that the as years of education increases by what?
So
by 1. I should see everybody's one finger. As years of education increases by 1 year, right? What happens to salary?
Salary increases by $4,107.
Perfect. Okay.
Yeah.
But Miss Simone, don't do that, boo boo, and now forget everybody else in the room. Okay.
Right.
Don't do it, because grandma's gonna talk about you. You know, uncles, everybody is going to be angry with you because you did not acknowledge the room. So please acknowledge the room. Anybody. So as years of education increases by 1, salary increases by $4,100. What else?
Holding all variables constant.
I don't, because I'm not gonna go into that room and be like, "Hey, everybody." Not in my culture. You go, "Hi, auntie, so and so. Hi, auntie this. Hi, cousin that. Hey, grandma this." So I need to hear everybody's name.
Oh wow.
Yes. Yes. Anybody? Gerard is on mute and he's just talking away.
I swear I thought I was talking the whole time. I was just saying holding years of service, age, gender, and race constant.
Years of service, age, gender, I like that. Yes, because some people go holding male constant or holding female constant, but that whole variable is gender. Good. And then what was the last one?
And race.
And race, because that's one whole category, right? We can't say holding Asian and black. No, the whole thing, we have to hold it constant because it's one whole category of a variable. Okay? That literally is the difference between lecture 6 and lecture 7. Do we know what Y is? It's the same Y as lecture 6. Do we know what X is? It's the same X, but we got many of them now, right? Mm-hmm. Do we know what B naught is? Let's try B naught, because that one's a little different too, just like B1s, all the B's, the regression coefficients. So if we remember, your y-intercept is
your B naught.
B naught, yes. And that is your expected your expected Y, your expected variable. So expected what? Expected? What's your dependent?
Is it salary? Yes. Salary in dollars?
Yes. So your expected salary when what?
When everything else is holding.
Yes. So what is it? Like, say it. So your expected salary is negative $30,307 when, somebody fill in the blank.
Years of service.
We don't exist.
Race is 0.
I don't like that, Gerard. I don't like that. Somebody help him out.
When you don't exist, like you've not been born.
Whoa, I don't like that one. No, you don't exist. No. Anybody else? Any other takers?
Oh, I think it's because we forgetting that the reference group is
good.
It's white.
Is that right?
Is it okay? Because that's what we don't see here. All right, it's white. Oh, okay. So we can't say when age, when race is 0, because here I'm giving someone results, and I say, oh yeah, it's when age is race is 0. They'll be like, what does that mean? Like, this is layman's terms. This is tell me what you learned. You're not gonna go to mama and be like, oh yeah, when race is 0. Or when gender is 0. You're going to say what those things are. So go for it. Let's list them out. When years of service, years of education is
0.
When years of federal service is
0.
Continue.
Also when you're white.
Not that. No. Keep no.
Age.
One. Age is age.
0?
Yeah, 0 newborn, yes. Continue.
Female, because it has to equal 0.
Oh, 0, so female. Okay.
Good. And then the race one.
White.
Perfect. So that's
it's a white female newborn.
White female, yes, 0-8 years old with no years of service and no education.
Can I ask a question?
Education. You got that?
I got it, but that was, I don't know why it's so complicated at first.
Yeah.
Oh, okay,
Right.
okay.
It was so complicated. Like I was just saying, yeah, this is the y-intercept, and this is why because it's that because it's b naught.
Okay.
That's kind of how I was explaining it. But now that I see how you broke it down, I see how you did it.
Okay.
Yeah.
So, and here's the thing, guys. It's in here too. So I don't know which one people do, whether it's the slides, like the PDF slides or the YouTube. I mean, I think the PDF slides are more updated. More updated because I did them recently, redid them recently. But if you read through here, right, it tells you exactly what we just said, my people.
Yeah,
Right?
it does. Mm-hmm.
So help me, because I am an educator and I actually love to educate. I would love to know where the disconnect is so that I can do this better. Where's the because you guys are getting it now. I want to know what happened.
Pressure of the test. You don't
Yes.
remember everything when you're being quizzed and tested.
Mm-hmm.
You know, if I'm sitting down to do the homework, the practice exercises, I refer to my handout and everything else. But while I'm doing the quiz or the test, it's a lot of information. So
Okay, no, I hear you.
Yes.
And I would like to ask why. Okay, no, not why. Do you feel like you have it though? Oh, Christine has her hand up. Okay, I'm coming to you, Christine. Do you feel like you have it before the quiz? Because if you're feeling like, oh shoot, I wish I could refer to these notes, then do you have it before the quiz?
I do have it for the quiz, but I think for me, I can speak for myself.
Okay.
It's the pressure of the test and the time. The clock is winding down. I have to go look to find, okay, which handout, what does this have to do with? This has to do with multivariate. This has to do with T-stat. Okay, all right. And then, it's that kind of pressure.
Okay. Is there enough practice? Do you feel like you get to practice enough, or are the answer keys clear enough? Are the lectures clear enough?
I would say, I mean, I know we just talked earlier, but like I know the lecture is definitely clear for me. You definitely go down, break it down, or I'll even sometimes like rewind, and then like once I get it again, I'll go along with you. So it's not so much the lecture. I think I don't remember the lady's name, but I agree with her. Like it's that the
Simone.
Miss Simone. So I agree with her with the quiz because it's like it's time. And I mean, even though it's only like 4 or 3 questions, like I could get the answer down if it's just numbers, but the interpretation, that's where I struggle. I'll be like, oh gosh, I'll be like, okay, let me get myself together, and then by the time I get it together, I feel like the time is like 5 minutes left.
Yes.
And I'm just like, oh gosh, I still got 2 more questions. You know what I'm saying? So I don't know it, but like the practice is good. The answer key is good. I think it's just the pressure, like she said, Miss Simone said, of the quizzes.
Yes.
Okay. Okay. Christine, you had a question?
Well, not a question. I was just going to try to answer the question. I know for me, kind of along the line with like what Gerard has said and Simone, because like when I'm taking, my struggle is not necessarily the identifying what is what per se, but it's like when it comes to like actually kind of interpreting.
Yeah.
And when it comes to like the negative versions or like even in like the recent stuff, it was like, sometimes I get confused in terms of like when it's negative numbers, because I feel like sometimes in the practice stuff or in the videos, like it's a little easier.
True.
Versus where like when we do the quizzes or stuff like that, it's a little more complicated. So like it's easy for me to do the expected salaries when like things are positive. Like I'm like, oh, okay, great. but then like when you start doing the negative stuff and like negatives and positives, I'm like, wait, is this increases or this decreases? Like I get really confused.
Yes.
Okay. Okay, so let's continue. Oh wait, Stephen.
Not a question. I just wanted to answer both your questions.
Okay.
You asked us if the practice is enough, if the lectures are enough, and if the videos are enough.
Yes.
Is yes, they are.
Okay.
They're sufficient. Good. I think they give us sufficient practice. But I want to agree with everybody else that there is that pressure when we are taking the quizzes. I think that makes us overthink some of these things and bring confusion.
Most definitely.
All right.
Okay. Okay. Time. So the midterm, the final is gonna be the same 3 hours. Is that how was the midterm?
So that 3 hours, I keep talking about it because I saw 3 hours and I was like, oh, we have enough time. I used every single second, every minute.
No cap.
No kidding.
It was a lot, only because like I was trying to remember the Excel stuff and like that it was a lot, and then like sometimes like the issues that I have is not some issues that may have like popped up
Wow, this is interesting. I'm trying to manage all of this.
You did your stuff.
And like I was telling you earlier that like I'll be following the lecture as far as the homework. I don't know if anybody else have like a Mac or a different computer. But I have a Mac, so when I think on like if you see on YouTube it's a Windows, so I'm trying to follow exactly what she's doing. But like since I have a Mac, it's definitely different. So I have to spend like a little extra time like getting it together. And sometimes, especially at that midterm, it wasn't the equations. I don't know if y'all remember what lecture it was, but where you had to enter the equation for the mean.
Yes.
The mean range, mode, stuff like that.
Yeah.
For the midterm, like it was not allowing me to do it. It'll say null.
Yep.
And I don't know if it was anybody else, but I know that's one of the troubles I was going with the Excel. So
okay. One we got Blair. Blair, you had your hand up. Wait, Steve, you had your hand up again?
No. I just wanted to agree with Gerard about when we were filling in the blanks, I kept deleting them, but I think I put a note there saying that it keeps deleting it. Like you couldn't see that we are putting in the formula because it would disappear once you put it.
Wow.
Yeah.
Okay, Blair.
Yeah, I just had a couple things. One, I agree kind of, I forget which lady mentioned it, but she mentioned something about like the YouTube videos are great, the practices and the homework are great, but kind of when it comes to the quizzes, sometimes it can be a little off. It seems a little difficult. That was just my feedback I wanted to give. But the question I have is there a particular way that you recommend studying for the Excel portion on the final?
I would do as like the way I said you should study for the midterm would be to just go back over the Excel homeworks without the assistance of the instructions, because as you've already seen with the exam, it just says do this. It doesn't say step 1, step 2. So I would maybe work on it with the instructions, and then the third go, try to see, because these Excel exercises are literally, if you're comfortable enough doing it, it shouldn't take an hour. It should take more like 15 to 20 minutes.
Wow.
Yeah, I know. So this is not to. These are not here to go. I'm gonna make it's definitely not that, because yeah, that's not my MO. But but if you get comfortable enough with it, it should take like 15 to 20 minutes.
And you are correct, because it's just certain ones. It's really just like 1, 2, and 3 Excels are easy because it's row, column, total. 2 Excels is easy as well, but it's lesson 4 and the last one we just did.
4 and 5.
Oh, regressions.
Yeah. So 5 is 5 is good for me because it's the row times column divided by the number.
Yeah. So I know
that's
what happened with lecture 2. Homework is probably also difficult. 2, 4, and 7 are probably the most difficult of them, and maybe where you need to hone in on, because lecture 2 it starts introducing you to recoding, and if you don't know how to recode, you are not going to get more than like 20% of the midterm part 2 or the final exam part 2. Like, you're just not going to get it, because you have to recode words to numbers so that Excel knows how to calculate. Because I don't know if you've ever seen a calculator, but I see numbers, and that's all calculators know how to do, is use numbers and give you answers. And so that's all we're doing with Excel for lecture 2 and 4, where we're recoding, lecture 7 where we're recoding, is getting all those words to mean something to Excel, right? So that it can give you an intelligible output. So coding is extremely important. Lecture 4, after you code, that there's nothing else to it, because you go to that data analysis tab and you select, correlation, or you select data summary or something like that.
It's descriptive
statistics.
Yeah.
And then voila, these tables come up, right? And maybe we need to talk through that too. Maybe we need to go over that. But let me get through this lecture before we, because it sounds like Excel really is an issue. So I want us to do some Excel stuff like really quickly. And I say really quickly, I hope it is. I'll try to make it really, it's pretty, to the point. So we'll see how we go with that. Lecture 6 and 7. Lecture 6 and 7. Why? Why means what? Gerard, I'm just going to go down the line. Why means what?
Y is the dependent variable.
Yes. X is what, Simone?
I'm lost. Hold on.
You can do it.
You said X is the regression coefficient?
Uh-oh. Tara, X is it Tara or Tara?
It is Tara, yeah.
Okay, Tara, X is what?
The independent variable.
Okay, good. B naught is what, Christine?
Hold on for a second, sorry.
Okay.
B naught would be the independent variable.
B?
Like constant.
Okay, I got my notes now.
Okay, Simone, what is B naught?
The y-intercept.
Okay, tell me what B naught means.
B naught means what the, hold on, when it's 0.
Blair, tell us what B naught means.
The expected value.
Okay, Blair. B naught is Blair.
The y-intercept when it's 0?
B naught is the y-intercept. So Jessica, on mute. What does B naught mean? Jessica still on mute. Jessica will remain on mute. Steven, what does B naught mean?
The expected values of X when everything, when everything is 0.
Okay.
Of the independent variables.
Yes, so the expected value of, give me another word for Y.
Of the dependent variable.
When
everything else is 0. The independent variables are 0.
When all of your independent variables have a value of 0, right? That is what your y-intercept means. That means that is what your X is, your expected, that is what your Y is, your dependent variable is expected to be when all of your X's are at 0. We're good? But
would you mind just repeating that one more time?
Okay. When all of your X's are at 0. When all of your X, oh goodness, why is this in my way? I can't even. Okay. Wow, so many things in my way. Can you guys see all this that I'm seeing?
Mm-hmm. Yes.
Yes.
Like I can't even see. Okay, so B naught, the expected value of Y when X is 0.
Is 0.
So this is lecture 6, right? Where there's only one X. So that's why I say when X is 0. But for lecture 7, I would say when all X's are 0, right? So when you look at your equation, however many X's you've got, when all of them are 0, you're multiplying everything by 0. What's left? The one constant that's not multiplied by anything. You see that?
Yeah.
Thank you for that.
Okay. So I don't know how to like drill it in, except for to say you gotta practice it.
Yeah.
You weren't born knowing this.
Yeah.
And you are however old you are, and you did not know this until this age. So it's not like you were learning this in nursery rhymes and learning this in primary school or elementary school. No, you're just knowing this. So it's not gonna necessarily, some people it sticks like right as soon as they hear it. Some people it takes a while. So you might need to like really just keep saying it over and over, seeing it over and over. Let it stick. Okay? So, I wish I could see more people. Oh, it's not that many people that are on the this thing here. Okay. So, we're done with lecture 6, I believe. I'm going to close that out. We're going to close lecture 6. We're going to lecture 7. We're good. Close that out. We're going to go to lecture. How is lecture 8?
That's the one with beta weight and what's that? Beta weight and
R squared.
And regression coefficients, yeah. And R2.
R squared.
Yeah, I said R2, R squared, sorry.
Okay, so how do we feel about lecture 8? Good? Because if we understand regression coefficient, huh?
Would you mind just briefly going over lecture 8?
Oh, okay. Okay, so lecture 8, I'm just going to close all this. So, lecture 8 deals with beta weights and R squared. So, beta weights, and if you notice, I sort of always give like a brief overview, even though it doesn't make sense at the beginning because you were just learning it. But at the beginning, I always say, this is what we're about to learn. Like, this is the brief overview, then I get into it. Like for regressions, I said, the purpose of regressions is to make predictions. So here's how we make predictions, okay? So now, lecture 8, the purpose of R-squared is to understand how strong that entire model is. What's a model? A model is one dependent variable and all your independent variables with their regression coefficient. That's a model. So how strong is this model, right? All these independent variables, how strong are they in helping us do what regressions are supposed to do, which is predict your dependent variable. So how strong is this model? All of them working together, all of the independent variables working together. How well are they working together to help us understand and predict salary or whatever the dependent variable is, okay? Your beta weights, I mentioned they are very similar to regression correlation coefficients because they are. Regression coefficients have beta weights that work just like correlation coefficients, except for you have to hold things constant when you're dealing with multivariate regressions. Okay, so beta weights, unlike R-squared, where it's there to see how everything helps you predict that dependent variable. Together, they're working together. Beta weights, they're working individually. So they're saying which of us is the strongest, right? In this, who's the weakest link? Who's the strongest link? So with beta weights, we are competing. You know, education is competing with years of service, is competing with age, is competing with race. They're all competing to see, you know, to see which beta weight is the highest, which beta weight, you know, is pulling the most weight, beta weight. Okay. And so, so there's lots of, what's it called, examples here, lots of interpretations here. So I think that if we go through these at the end of it, I pray that you're more clear on all of this. So we have our little output here. We've got our beta weight, we've got our regression coefficient, and we've got other things here, but that's for lecture 9. Okay, so lecture 8. Lecture 7, from lecture 7, we were able to interpret these beta weights. Somebody tell me quickly, what is the y-intercept in this output?
The constant.
What is the y-intercept in this output?
-24435.2.
Thank you. What is the dependent variable?
Salary in 1991.
Okay. How many independent variables do we have?
1, 2, 3, 4.
1, 2, 3,
9,
5, 6, 7,
4,
8, 9.
Yeah, I'm counting 5, 4, 1, 2, 3, 4, 5.
Oh, yeah. If I looked at the numbers, I wouldn't have confused myself.
So I'm counting years of education. I'm counting years of service. I'm counting age. How many is that so far?
3.
I'm counting gender. 4. And I'm counting race.
5.
So we have 5 independent variables.
Oh, I see. Okay.
Okay, 5 independent variables. Now that we have a set of dummy variables that make up one independent variable, but this is a set that just makes up one. Like this is 0, 1 is coded as Asian, 0 is coded as what? As
female.
What? One is coded as Asian.
No, I'm looking at the wrong thing. White.
Okay, 1 is coded as Black, 0 is coded as
Asian. I mean white. Sorry, white.
Wait.
Okay, listen. Who is talking? What is going on?
Sorry.
Okay, 1 is coded as Hispanic, 0 is coded as
What?
Praise the Lord. 1 is coded as Indian, 0 is coded as
white.
Right. So these are all ones. This one variable that has been broken down because you have to do this for nominal variables. For nominal variables, because you can't say, oh, white is greater than Hispanic and Hispanic is greater than, like, you can't say that. There's no such thing as that. So you just have to break them down into their separate variables that you compare with a reference group. That's all that's the only reason why we do that, because that's the only way we can actually make interpretation. All right, so what was the purpose of me? Oh, so we know lecture 7, because you guys said let's move on. So let's do a quick review of lecture 7 before we do move on to beta weight, because we got to know how to interpret this column before we can know how to interpret this. So this, no, this is written here, so I don't want to do that one. Let's do the next one. $730.58. Somebody tell me, what does that mean?
So somebody can go.
Christine, I think, was about to say.
No, go ahead, Gerard.
Christine.
No, Gerard got this. Go
Christine.
I feel like he's so confident he can get this, man.
No, we don't need the confident one. Gerard is good. Christine.
So where we got years of service? Yeah.
Yes, 730.
It's saying that as years of service increases by year, it increases by the 730.
Wait, as years of service increases by, and then I didn't hear it.
As years of service increases by 1,
okay,
your salary increases by $730.58. Wait, what did I say? This is small.
Yeah,
$730, and I'm just gonna round it up. Well, round it to 58 cents.
Yes. So as years of service increases by 1 year, salary increases by $730. Notice what I'm stressing, emphasizing here. Years, that's the unit of measure for service, right? Federal service, how long you're employed at the federal government. Salary, I'm talking about it in dollars, so I said $730. Okay. Now the huge, amazing thing about beta weights is that and this is what I talk about here, is that they help us standardize and compare. They help us standardize all these variables in order to compare. Okay, because 1 year of federal service is not the same as 1 year of 1 year of education is not the same as being born and now you're 20, now you're 30. Now it's not the same. Why? Okay, I can have 26, 28 years of education, right? And that's probably the max. But people live to be 100, right? So they can't be compared, because one has a span that's like this, another one has a span that's a lot longer, right? Years of federal service, somebody might retire after 40 years, right? And 40 might be the highest for that one. Whereas, again, years of education, still not as high as even that one. So we've got years of education, years of service, and years of life. And they're all different measures, and they can't be compared. Why is my baby screaming? Jesus. 1 second. He needs to eat. And hi, sweetie. Can you come and get his food? All right. Oh my God. Okay, sorry. So, he's 6 months. So, that's my life. I can't even remember what I was talking about anymore, Lord Jesus. Yes. So the different and that's years, and all of them have the same unit, years, and even that you can't even standardize because they're all on different scales. And now go to gender. How do you compare gender, was just male and female, to years of all the different scales, right? How do you measure race to that? Like how? And so the beta weight, and that's what I talk about in this slide 4, is helping us understand that. Before I dive into the examples, beta weight is helping us to now, put them all on the same scale and say, all right, at this scale where everybody's equal, what, hey, Boma, what does, who's doing the most damage, right? So we see here that years of education, 1 year gives you a salary, boosts your salary by $3,200. And another thing that I want to say before we even talk about that, because this is the reason why some people have gotten the answers wrong on their quizzes or whatever, is because they'll say, as years of education increases by 1, hear me, as years of education increases by 1, salary is $3,200. Show of hands, please. Let me see everybody's faces. Who wants a salary of $3,200? Who? Anybody? No? No? Because that's not what this is saying. This is not saying that your salary is now $3,200. If that's the case, forget it. I don't need an education, right? Like, it's saying that your salary increases. It's here, it increases. So don't say that 1 year of education gives you a salary of that. 1 year of working gives you a salary of $730 for 1 entire year I worked, and you want me to have $730 for that 1 year? What did I work for?
Right.
Do we see the difference there?
Mm-hmm.
Okay, good. Yes. All right, so now, based off of what we're seeing in the unstandardized coefficient, the regression coefficient, what are we seeing as supposedly the strongest link, the one that's doing the most damage here for salary?
Male?
Yeah, or Indian,
gender,
or Native American, I guess. So that seems to have a very high number, right? 6,000, right? But then we go to the beta weight, which has balanced and neutralized everything, and then we can see really where who's doing what. If you remember correlation coefficients, right? Sweet love.
Oh, poor little baby.
Sorry. Okay. 1 year of education, sorry, that's not what I was going to say. With the beta weight, we can see here, based on our correlation scale, if you remember it, would it be strong, moderate, or weak for education? That was you, Tara?
No.
Oh, who was that? I don't know why it's showing me Tara.
Christine.
Who was it?
It was Christine.
Christine, okay. Okay, bold Christine. Say it again.
Moderate.
Moderate. So it's moderate. We could also say this one is also moderate. And these ones, what would you say? Why is it so low? What's going on? Who's talking?
I would say weak.
Yes. So this is practically 0. This is 0.2. It's weak. This is 0.02. Still practically 0. All of these. So we can see that even though gender and Indian, as it relates to white, have the highest numbers here in regression coefficients, they're not really doing much for salary. Do we see that?
Right.
Here's what's happening. This is a comparison between males and females, right? Males have a salary that's $6,000. Would you say more or less? More than females. Okay. Here you would say Native Americans have a salary that's $6,200. Which one would you say more or less?
Less.
Continue.
Than white.
Right. So this is comparing, these are dummy variables. So they're comparing just two groups, right? Two groups of people, male, female, and then on the race scale. And so, but it's telling us that generally race is not what's you know, what causes you to have a salary or not, a certain salary or not. But we can see here that whites generally are the ones making more than all the other race groups. Okay. But age also, it doesn't mean that age is doing much either. So every year your salary goes down by about $10, $11. But in the grand scheme of things, not much of a difference in salary. So what's making a huge difference? It's your education. What's making a huge difference is how long you've worked at the federal government. But now we go here and we see that 1 year of education made a huge difference for your salary, $3,200 versus $730. Over here, they're practically the same, moderate relationship. Education is still stronger, but they're practically the same. Not so huge the way the unstandardized is showing us. Okay, so with that basic overview of what this lecture is about, this now tells us that what 1 year increase, sorry, we're standardizing. So as education increases by 1, we're not saying year anymore. As education increases by 1 standard deviation. Okay, everything has been standardized now. So as education increases by 1 standard deviation, what happens to salary? It increases by almost half, 0.5, right? As years of service increases by 1, what happens to salary? 0.43 standard deviations. So if you know how to interpret your regression coefficients, all you're doing here is you're dropping off the actual units, right? And you're saying standard deviation.
So then the dummy variables.
Still with us?
Did you say it?
Yes, ma'am. I'm here. I'm following along. I'm just taking notes.
Okay. No, I know you were the one who specifically asked, so I just want to make sure everybody's good. Everybody's good.
Yes, I'm here. Thank you.
Good.
How would you do the dummy variables?
Good. So with the dummy variables, Christine, you were the one who asked that?
Yeah.
Okay, give me Asian for regression coefficient, unstandardized.
What do you mean?
Give me the interpretation.
So Asians make less than.
How much less?
Oh, they make $2,086 less than whites.
Okay, don't disrespect everybody else in the room now.
Holding.
Oh, holding. Holding years of education, years of federal service, age, and gender constant.
Good. And that's it. So Asians make $2,086 less than whites, holding those other 4 variables constant. Okay. And then you go over to beta weight. Remember, we're talking in the same lingo. So Asians have a salary that's 0.024 standard deviations less
you would say
than, huh? What? Did I miss something?
No, I was just trying to figure out, do you say the word decrease? So no, you just say.
Oh no, I said less. Just like with what you said the Asians make 2,000 less than whites, right?
Oh.
So Asians' salary is 0.024 standard deviations less than whites, holding those other 4 variables constant. So if it becomes hard, I give all of that background because if this becomes hard, just go here, interpret it, remove the units, years, or whatever it is, salary, and just scratch it out and put standard deviation. Okay.
Mm-hmm.
And that's literally what we talk about here, and then we go into what we did with correlations, which is rank them. So what's the strongest relationship here with years of with salary, which based on the beta weight, education, yes, and which one is the weakest?
Hispanic. Oh wait, no, birthday, age.
Yes, age. So, how do we feel? Good. So now let's go on to the coefficient of determination, which is also known as R squared. R squared is a way to calculate it, and I show that. But the big deal here is, what does it mean? Right? And so most times you're gonna get, all the times, if you run a regression, you're gonna see the output. If for whatever reason the output doesn't come, this always shows up. And so that's why I'm just showing you how to calculate it. But at the end of the day, you have your R squared, you just need to know what it means. Okay? The first R squared shows us 0.95. The second R squared shows us 0.033. 0.95 means that it's a 95% R squared. 0.03 means what then?
It's a 3%.
Huh?
Is it 3%?
Yes, 3.3%. So now what does that mean? what does that mean? So it means that model, whatever independent variables are in that model, in this case, it's telling us our predictors are only pay grade. In the next one, our predictors are only age. So first of all, is this a multivariate or a bivariate?
Bivariate.
Yeah, so this one is only age and grade and salary. This one is only age and salary. So these are bivariate relationships. Now we know in lecture 7 and 8 we've had multivariate regression. So the R squared C or have more than one predictor. It's going to list all the predictors. Okay, all the independent variables. So R squared here is telling us that grade helps us understand or predict 95% of what of the variation in salary. Okay. I'm listening for feedback.
Yes.
Age predicts or helps us understand only 3% of what predicts salary. So which one is telling us more? Well, in this case, it's real simple because your pay grade literally is your salary. So they're very highly correlated. There's no reason to even do a bivariate regression about it, right? Because we know that if you have a salary of 78,000, you're probably in the pay grade that corresponds to that. So it's right. It makes sense that the R squared is so high. Totally makes sense. Mm. But we know that it's not 100% simply because you can have a pay grade of I don't know what that is. That a 9 pay grade? But it could also be an 8, but it could also be a 10 because these pay grades are so wide, right? And so that's why as pay grade increases, salary increases, but that doesn't necessarily mean that it perfectly predicts it, because a pay grade, a salary of 78,000 could put you in pay grade 7, 8, 9, 10, just because of how wide it is. It might be the very high end of pay grade 8 and the very low end of pay grade 10.
Can you go back through that, because you was frozen? So I don't know if you kept talking while you were frozen.
Yeah, I was like, what the world?
Okay. I need some water. Okay, so so what did I say? What did you guys not hear? I'm trying to figure out.
The last thing you said was about which one predicts more, like which one is higher. That's
what? I said a lot. Okay.
A little bit.
So what I was saying is that pay grade, the reason why, I mean, it doesn't even make sense to do a regression between salary and pay grade because they're practically the same thing. Okay. And so a pay grade of 70,000 or something, 80,000 could land you in, a salary of 80,000 could land you in a pay grade that's in pay grade 8. It could be pay grade 9. It could be pay grade 10 because 80,000 is housed in all three of those. It might be the high end of pay grade 8, but the low end of pay grade 10, and the middle end of pay grade 9. So that's why it doesn't predict it perfectly, right? But they're so highly correlated that it doesn't even make sense to do a study like this. This is just for teaching purposes. That's all I was saying. And then I was also saying that pay grade clearly predicts a lot more than age, right? Because for that very reason, that's why it's 95% versus 3%. So federal employees' pay grade explains 95% of the variation of why salary increases and decreases. That's the variation. It explains why salary increases or decreases, about 95% of why it increases or decreases, whereas age only contributes about 3%. That's it. And notice that the sentences are literally the same here. And all I did was remove pay grade and put age, right? They have the same dependent variable. And so if you understand, I mean, the goal is just to understand what these numbers mean, but it doesn't mean you have to say them all different each time. You ain't got to be fancy. No need for fanciness, because you're saying the same. If you only know one way to say it one way, If you want to get fancy with it, say it this way one time, say it that way another time, as long as you're saying the same thing, but, Okay. How do we feel about lecture 8? Okay. Do we need to do lecture 9?
8. Yes. 9. Just a review. Where is it?
Okay. Okay, so lecture 9. Let me close this one. Lecture 9. Okay. Lecture 9 is a fun one and a very repetitive. Well, actually, I think everything post midterm has been very repetitive, and so if you practice it enough, trust me, it is so repetitive that it's just no other way about it. You learn it and then you just keep saying it over and over because it's all the same. So the first thing was t-squared, then p-value, and then confidence intervals. Okay, so let's look at a multiple regression here that has a dependent variable of BMI, body mass index. And how many independent variables do we have here?
5.
1, 2, 3, 4, and 5. Age, restaurant, exercise, TV, and gender. Okay. So the first thing we looked at was T statistic. T statistic, here's the rule. 2. T2. Everybody say it with me. T2.
T2.
Good. Okay, T2. The rule is if it's higher than if it's higher than 2, right? What do? We reject.
No.
Because it now means that it's high enough to be accepted, to be generalized in the population. 2. So that means something like this, right? Is it higher than 2?
Yeah.
It's negative, but we need 2 on either side, whether it's -2 or +2. It just needs to be in the no and fly all you want zone. Fly all you want, right? And when it's in that zone, you reject the null hypothesis because this area here is saying, it's a little murky, we're not sure, and we don't want to chance it. That's why we say, all right, then let's not generalize what we're seeing in this sample. Let's not generalize it to the population because it's a little too close for comfort. Okay. What was I? I thought actually that's when you said that shit. When you said that, who is talking? My oh my. Okay, so here we are. So T2. Which other ones can we generalize to the population? Can we generalize age?
Yes.
What?
Yes.
Can we generalize restaurant?
No.
No.
Exercise?
Yes.
TV?
Yes.
Wait, I'm confused. What are we talking about?
No.
No.
We're here with P-STAT. We're looking at whether we can generalize to the population. So again, the people who didn't respond, let me hear you guys only. So age, can we generalize to the population?
Is this when you reject or when you reject, you generalize?
Okay, so let's do that. So for the T-STAT, we're gonna say reject the null or tentatively accept the null. So age, do we accept or reject?
You reject.
Greater than 2, reject.
Okay, next, restaurant.
Accept.
Okay.
Reject.
Exercise, reject. TV.
Reject.
And gender. Accept, because it's less than 2. Okay, so accept equals not generalizable. Accept equals not generalizable. Reject equals generalizable. So what we're seeing in this sample, we're expecting that we'll also see it in the population. Okay. P-value. P5. Say with me, P5.
P5.
Okay, and then T, what was that one? T?
2.
P2. P5. T2, P5. Okay, and here's the rule here. If it is less than 5%, right, we reject. If it is more than 5%, we tentatively accept. What is 5%? What does that look like here? Is it 0.5?
Yeah.
No.
0.0. No.
It is what?
0.05, they're all the same thing.
They're all the same thing?
I thought it was like if it's 0.05 or 0.5.
No.
No.
So what is 0.5?
I have.
What is 0.5 in terms of percent?
50%.
50%.
50.
Oh.
What is 0.05?
5%.
95.
Well, yeah.
5%. 0.05. 5%. 0.5. 50%. Very huge difference. Okay. So P5 is the rule here. So age, do we accept or reject?
Accept.
Okay, let's try it again. Accept what? What are we accepting?
Oh, if it's over 0.05, so we reject.
Okay, so this is practically 0, so it is definitely less than 5. So we reject. Just like this is higher than 2, we reject. Reject. And I know part of what I think I said it here. The results are always consistent, right? So if you said reject here, then it's not. Yeah, so this is going to help you confirm, make sure you did this one right, because this should tell you the same exact thing. And this should tell you did accept. Did somebody say wow?
I did.
Yeah, wow.
What? Are you literally just saying wow? Like you just got that?
Yep.
I love it. Okay. So so if you said we can generalize to the population here, then this should tell us the exact same thing, and this should tell us that exact same story. Okay, so P2, we're higher than 2, so we said we reject the null, we reject that there's no relationship, we're accepting, I don't want to say accept because that would confuse people, but we're generalizing to the population. So T2, higher than 2, so we reject the null. P5, lower than 5, so we reject the null.
Right.
5.
I have a question.
Okay, 1 second. 5 means P. This is the probability of error. Remember, probability of error, and that's why we don't want to be higher than 5. We are only willing to accept 5% error or less, and so that's why we're saying 5 needs to be less. But I mean,
oh wait, if it's less, wouldn't so? See, now I'm confused. I hate math. So if it's less than 5%, you reject.
Yep.
When if it's over, you accept. But in the restaurant coding, because it, oh wait, forget it, scratch it. Scratch. I fixed myself. You're fine.
Okay. So age is less than 5, so our probability of error is much lower than the 5% that we're willing to accept. So we reject the null, and we can generalize to the population. Reject and generalize. Restaurants. There's the 5 rule. What percent are we looking at? Anybody?
77.
Yes, 77.8%. Is that higher or lower than 5%?
Higher.
Obviously
Higher. So accept or reject?
Accept.
Accept the null. Good. Which means we cannot generalize to the population. Next one, 0.004. What percent is that? 0.4%. Accept or reject?
Reject.
Well, it's less. So
yes, we reject and we generalize. TV is just like age, so we do what?
Reject.
We reject and we generalize.
And generalize.
And then gender, what do we do there?
29%. So we accept.
We tentatively accept the null because we're not sure what's going on in that little no fly zone area, and we cannot generalize. Okay, so far T2 is telling us the same thing as P5. And then the last point here is the confidence interval. So the confidence interval is telling us that if you see the coefficient, the regression coefficient, this is for the sample, okay? As age increases by 1, what happens to BMI? It increases by 0.9. You with me? That's in the sample. This particular sample, that's what happens. In the population, this regression output, because it predicts, remember, it's predicting that in the population, as age increases by 1, holding those other 4 variables constant, what happens to BMI? Well, it could increase anywhere from 0.538 to 1.317. It can increase anywhere between that range.
In that range.
Can you do a negative? Because I think I get more confused when I start doing the negatives.
Yeah, that's fine. We're going through all of them. Okay. So as age increases by 1, right? BMI can increase by 0.538, 0.7, 0.1.1. I mean 1.3. Can it increase by 1.9?
No.
Right. It's outside of that 95% confidence interval. So it's telling us, since we can generalize to the population, this is what we expect for age to increase by that gap, that range there. So can it increase by 3.7? That's not part of the range. Okay?
Mm-hmm.
Let's go to restaurant. Oh, wait. Let's stick with age first. So T-stat, we said we could reject because it was higher than 2. P5, we said we could reject because it was lower than 5% error. Now we're also saying we can reject the null and we can generalize to the population. Here's why: because we are clear on how it can move, how age can move BMI from 0.5 to 1.3. This is going to be important because of this next one, restaurant. All right. As restaurants, visiting the restaurant once however many times a week increases by 1, what happens to BMI? Well, it tells us that it can decrease BMI by 0.142. Or
how did you get that?
The negative.
Oh, okay. Lower 95%. Okay, I was okay.
So good. So it could decrease BMI by 0.142. Right? And we're going, if we're looking at a range, right? Negative 0.142 all the way to positive 0.189. So it passes through 0.
That's why we're working together. It's more important.
Is someone having a question? I don't know what's going on. Okay, so it's decreasing by 0.142. BMI is decreasing by 0.142. Let's go along that scale. We could pass 0. So that means it could have no change at all on, no effect at all on BMI. Or it could increase BMI by 0.189. It could do a bunch of things. This is telling us that it is completely not conclusive. We don't know what restaurant usage does to BMI. Do we see that? It could decrease BMI. It could have absolutely no change in BMI because it crosses over 0. And it could change BMI in a positive direction, giving us a higher BMI. And so as we see that, let's take a look at our T-stat, T2, our P5. T2 told us that it's less than 2, right? So what did we do?
We
rejected it.
The null hypothesis.
Wait, no.
We did what?
We accepted the null hypothesis.
We accepted the null hypothesis. The null meaning
the
no
T,
relationship,
not the P, the T.
has 0, right?
Okay.
It's at 0. So if we remember that scale, let me see if I could find it quickly.
So when we accept the null hypothesis, we're stating that there is a relationship. There's a relationship between the independent variable and the dependent variable.
Yes. When you reject null, when you reject 0, right? Reject that there's no change. Remember when we were having to state the null and state the research hypothesis? The null hypothesis is that there's no relationship. Remember that? And then the research hypothesis is that there is a relationship. So when we're doing this, we are either accepting or rejecting that null hypothesis, right? Was I trying to show? I don't even remember now. Okay, so
you were trying to, yeah.
Okay, so I think we can use this. So that T2 rule, right? The T2 rule, and we can see that the T for restaurant was 0.28, and that's in here, right? It's somewhere like right here, 0.28. And so that is in our tentatively accept the null. Why? Because and that's why we have to tentatively accept it, because our confidence interval provides even more specifics than what this was telling us. This was giving us a hint that our confidence interval was unclear. And then we go and see the confidence interval and see, wow, it was unclear. But this, if you didn't have time to bother with the confidence interval, this was going to tell you, by the way, it's clear or it's not clear. So this is telling us this is clear, right? And in fact, it's not just clear, for sure it's going to be positive. This is telling us we're not clear whether it's positive or negative, and here we go, we see it. This is telling us that what should this be telling us? Is it clear or not clear?
Clear.
It's clear, and it's clearly going to be what? Positive or negative?
Negative.
Negative. And then we come on over here and we see it. We see that as exercise increases by 1, right? You exercise 1 a day, you know, each additional day of exercising you do, what happens to BMI? Well, it
decreases,
right? From anywhere from 0.09 to 0.458. It can decrease by that much. Does it cross 0? Nope.
No.
So we are not unclear. We're very clear because we see it doesn't cross 0. We see this is less than 5. We see this is higher than 2. See how they're all working together?
So when you ask for the interpretation of the T-stat alone, would you just say that like it's not clear that there's a relationship?
No. Why would you say that?
I know some of your questions you're like interpret the T-stat. So then like
yeah. So do you look at the answer keys?
And then I just
Okay, so like the answer keys, and even now we talked about it, we would say that we can reject the null. Why? Because it's greater than 2, which means that it's generalizable to the population. The sample, what we're seeing here in the sample, is generalizable to the population. So that's sort of the lingo that you would provide in your answer. Not just, oh, I reject the null. I need to know why. And maybe as you're doing this, maybe in real life, if you're reading this in real life, you may not see it written in these research articles because they're assuming that we know. But for the sake of learning and taking exams and quizzes, I like to see it so that I know that you know why. Because it's a coin toss, right? You can say accept or reject, and you're 50% chance of getting it right. So it's not just a coin toss. I want to know that you know why. So for this highlighted one, we know why we're saying what we're saying because of the T2 rule, right? We know why we're saying what we're saying because of the P5 rule. And then what are we saying? We're saying we're rejecting the null hypothesis. We're rejecting the null because there is a relationship between the sample and the population. Yes? Okay. Should we keep going or we're good?
No, keep going.
Keep going? Okay.
My struggle with this stuff is always the interpretation part because I don't know. I just, especially when it comes to negative numbers, I just be confused. So you can keep going if majority of people want to keep going.
Okay, so let's do TV. What okay, we're here actually. TV, lower and upper bound confidence interval. Actually, let's do gender because that has a negative so that you can do it. Was it Christine?
Of course.
Okay, go ahead.
Wait, what am I doing?
Interpreting the confidence interval for gender.
Girl, I have no idea. Is it the comparison between female and male? Is that what we're doing? No, it's just no female.
So what can you say based on the confidence interval that you're seeing there? Negative 1.1 and 0.34. Can you talk about it some? What do you see?
What? It contains a 0.
Okay, good.
So I know that. Wait, is it reject? Wait. Oh, so you reject.
How about this? This slide we're looking at, read the second bullet. Read it out loud.
Oh. Whenever a 95% confidence interval does not include the hypothesized population parameter, you will be able to reject the null hypothesis to the 0.05 significance level.
Oh, it must be the first one. Sorry. Yeah, sorry. I'm so sorry. Please read the first one. But it's good to read the second one too.
Whenever a 95% confidence interval includes the 0, a hypothesis test with a significance level of 0.5 will result in failing to reject the null hypothesis.
So go ahead. What was that?
So you would reject it based on the confidence interval? It includes a 0.
Nope. Okay, read one more time.
It includes a 0.
So when it includes a 0, a hypothesis test with a significance level of 0.05 will result in what?
Failing to reject.
So failing to reject means we have to tentatively accept, right? It's the same thing. So we can't reject because it says we fail to reject.
Oh, okay.
Yes.
Accept. So we tentatively accept.
Yes. So when it includes 0, we tentatively accept. And if you don't know, or you're like, I think that's what we do, go on over to next door to p-value. Go on over next door to t-stat. And if you know those rules, you can confirm what you're trying to say in the confidence interval.
Right. Okay.
Professor Yu, can I just ask one question?
Okay.
I just want to clarify something. So
Dr. Yu's not me though. That's my mama. I'm Dr. Uzuchi.
I apologize.
It's okay. Go ahead.
I apologize.
It's
so
okay.
Just to clarify, T-static and p-value allow you to see if the sample surveyed is generalizable to the population, whereas regression coefficient is data that is significant to just the sample survey?
Okay. Yes. So everything before t-stat, everything on the left side of t-stat, even if there was the beta weight right there, like we've seen in other slides like here, right? As soon as you start t, as soon as you see t, everything to the right of t is talking about the population. What can we say about the population? Everything before that, right? Your B's, your beta weight, your regression coefficients, those are strictly the sample.
Got it.
So whatever you're saying here, you're saying about that 100 or 1,000 or 10,000 people that you surveyed. And then you move over here, as soon as T starts, that's when you can say, well, what I'm seeing here, I can generalize to the population, or what I'm seeing here, I don't know if I can generalize, so I have to tentatively say I can't.
Got you. Thanks. That helps for explanation purposes. Thank you.
Good. Okay. So we just did everything in lecture 9 now. Yeah. So I don't know if we have, we've been on here for, what time did we start?
That's
six. Oh my gosh.
Yeah, it's a long time.
I was so intense. I didn't even realize.
Yeah, I need to. Okay, I need to get off in like 15 minutes because I gotta pump. I gotta make some baby milk. So,
Okay.
sorry for the extra information,
No.
but I do want to go over some of the lectures. Let's do lecture 2 and lecture Excel, just so we can. I don't know. It's pretty cancel. I don't want, okay. Okay, there we go. Are you guys still with me?
Mm-hmm.
Okay, because they were saying my internet was unstable. I don't know.
I get that all the time on Zoom, at least once a day. I don't know why.
I'm completely zoomed out, honestly.
Oh my
I've been
God.
more busy with coronavirus than ever before because everybody, including church, like everybody wants to Zoom over something. I'm just like, oh gosh. So, okay. So this was a very, and it used to be longer, but I've shortened lecture to homework considerably. But it's still one of the more involved homeworks. So I want to go over it. Graph BMI by age group. Everybody is everybody okay with that? No, yes, maybe. Okay, so I'll just go through it. So we insert a pivot chart because we want to graph it. So we just insert a chart and we can say, yeah, give me both. That's great. So I would go here. Actually, yeah, this is not how I would start it, but that's fine. I like to start it inside the data tab, but that's fine. And then I do want it to go inside the existing worksheet. Homework, you see that it says homework M2, which is where I had initially clicked when I now went to insert pivot. And so if you're using a Mac, you just have to figure out where that insert pivot chart is. Okay, so that's that. And I want it for BMI and age groups. So age and BMI. And we can put it in here again. And it doesn't matter which one you put, right? And it says that in the instructions. It just doesn't matter because it'll show up the same. The data is the data. It's just a matter of which of these do you want where. So I would get rid of the blanks and the null. And I did that right here. I don't know if this is too small for you, but it's right here. There's a drop-down menu. Makes it nice and prettier. And there's nothing to delete. Oh, there are blanks. Why do they have blanks? But anywho, so that's literally it for number one. But see all all that went into it. But if you did it and then you go, oh, I remember that. Boop, 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 done. Okay. And if it wasn't the chart that I requested and it was the table, well, here it is. Okay. And you could delete that or whatever. If this is what I asked for, but then I said, hey, I need what's it called? A column percent or a row percentage table. All you do is come here, you change the values, it's a count. We want it to now be calculated as a column percent, a row percent. Okay, and we can change this to row percentages if you want. And now we have row percentages. Why do we know it's row percentages? Because at the end of the rows, it's 100%. You can change it. The column percentages at the end of what? The columns, it's 100%. Okay? So that's lecture 1, 2, and 3. Homework, essentially. Okay, so like I said, this is not to stress you out at all. It is supposed to really be like, whoa, this is so powerful and so quick. I'm going to do this at work and get a raise. Whoop, whoop. It's supposed to be that simple. And then you can answer questions to that. And then the second part is the recoding. Okay, so I show you how to recode gender, and then I say, I throw you to the wolves and say recode all that stuff. So to recode gender, and you can see there's so many other things here that will need to be recoded, but to recode, did I say gender? Okay, to recode gender, copy, you never delete, and paste. Okay, to recode everything, which is lecture 4, in order to put it into a descriptive statistic, what I just did would be very not good for you, because you would now need to remember to like take okay, so like for example, I recode this one, and I recode this one, copy.
You would have to move it all together, right? So it can be.
Thank you. Yes, so you would have to now take all of them and move them down, copy and put them here, and you'd be, stressed it out versus just selecting all of it, right? Copy, paste at the end, and then do all of your recoding at the beginning or something like that. Okay. So that when you are ready to go to data, go to analysis, and go to descriptive statistics, because it has to be contiguous, you need to be able to select all that. You can't be like, okay, I want this one, let me go get that one. Oh, yeah, I forgot that one. It's not going to accept it.
So question. This is Gerard here. So if we, like you said, it have to be continuous, which I understand. So we start from B and all the way to the end of the recode for lesson 4?
Just like this. You see this arrow? It's telling you that it's selecting all of that.
And go all the way over to the, so I see you just doing just B to J. What about the recode?
Well, we haven't recoded anything, but we're calling these the ones we're going to recode.
Okay.
Anything, yeah.
Okay.
Yep. So you just select everything you wanted to recode, or that you have recoded that you want to turn into descriptive statistics. Now, you accidentally select something that has all these words in it, then that's gonna not be good, because it's gonna keep giving you error messages like, oh, it's not numerical, blah blah blah. Okay. So let us recode. What's going on?
Can I ask one more question?
Yeah.
Can you recode in a different tab instead of the same tab?
Why?
I don't know. I was just thinking, because I remember, I feel like I did that in my homework before. Just organization.
Okay, no. Okay, so you mean clean the data like for the regressions? Because that's different, because you're having to create a whole new tab in order to delete those blanks, because that's the only way regressions are going to accept.
Okay.
So that's lecture 7. And that's the only reason why I would say, sure. But everything is here. I mean, like, if you don't need something, you can just hide it, You don't, the thing is, you don't ever want to separate, like, say you just did this and you said, I want to create get away. I want to recode this. And you go and you do all your recoding. You even decide, I'm gonna sort some stuff. Yeah. Like, you just start doing all this stuff. And then now you don't know who this person is. You don't know, right? Because you didn't bring in observation. So you don't know if this is person number 17, person number 107. You don't know. You have no clue. And your data is just completely, to me, lost now. It's like you can't even match it to its descriptor, this it's what's it called, identifier anymore. So that's why I stay away from just taking arbitrary variables, throwing them somewhere and recoding. But if you wanted to just not touch this whole tab at all, you could copy the whole tab, right? And copy the whole tab or select all and paste it here, you know, if that's what you wanted to do, and then start doing your recodes. But I still, I don't know, like for example, when I am checking the recodes, right? So let me just recode this real quick. Female, we're gonna make that 1, replace all. 256 will replace. We're gonna change male to 0. And that is what recoding is, people. Recoding is not going in here and saying, all right, let's get rid of this. And now, you know, like people do that all the time. And I'm like, what did you actually recode? Then you go into data and you want to run analysis and it's saying all you got are numbers. And oh, here's a better example. When they recode everything and then all they have left are these, and they select them and say, nope, we don't want this. So everything else is coded 1, 2s, 3s. And they simply play peekaboo with the other 3. The computer is seeing it. It's definitely there, but you are playing games, yo. You're playing games. So you need to not hide them and play peekaboo. You need to recode them. Like this don't know would be recoded as a blank, right? And that's how you fully recode. And I know I say that in here, but anyway.
Got it.
Thank
you for that.
You're welcome. So, and notice I changed the name because now we need to know how you code it. And if I have this title as female, that means I now know that female is 1, right? So I recoded because I wanted to show you that this is how I check, right? How you've recoded to make sure you've recoded. But if you have now taken all of your recodes into here and only the recodes are here, I won't, how am I going to check? And that just makes life a little more difficult. Do you see what I'm saying?
Yes, ma'am. Mm-hmm.
Okay. All right. So
that,
go ahead.
Not to cut you off. That's why you said, that's why you just want it on the opposite side of the last one, right?
Mm-hmm. Yeah.
Okay.
Yep. So once we recode, there was nothing else in this lecture except for, oh God in heaven, my little baby is screaming his head off. I don't know what my husband's doing. I love him to death. That's his best bud, so he must really just not be happy because he's never crying with his dad. He's never crying. I don't know what's going on.
Poor little dude.
Yeah, like he never is crying with him. He's just a good boy, you guys. Such a good boy. Okay, so this is the part that people were like, whoa, I was typing in stuff and it wasn't working. So I don't know why, but when you type count and you want the count of BMI, so I would go into the BMI and select and press enter. And it tells us that there are 100 observations. And we can confirm 1 because there are no blanks. Don't see any blanks. And we can go all the way down and it stops at 101, which means minus the 1 header. So that's not 100, 1,001. So minus this, that's 1,000. So we confirm that. BMI minimum equals, right? We start everything with equals. And then we go back to it. And we select it, press enter. Okay. And we do the same with all of them, literally. So this is what I do because I don't believe in doing things over and over and over. I could do that. Oh, no. I copy this, copy, and then I paste it here. This is not min, right? It's max, but it's the same column, right? So we'll just, and this is a range, and I'm telling you what it is. So it just equals B5 minus B4. Is everybody seeing that?
Mm-hmm.
Okay. And then remember, I copied this. So now we're doing average. Another word for mean. Okay. Doing it again. What do we call this one? Median. Mm-hmm. And so on. This is quartile. Oh.
Oops.
Okay. And then the quartile will go with the first quartile, right? And so on. So I don't know why it wasn't sticking, but when I go in, when I grade, I don't want to just see these numbers. I do this just so I can see your equation.
Oh, okay.
Coming from
okay, now we get it, Professor. What was happening was we could see, like you type in the formula, it gives you an answer, but you wanted to see our work, and we were like, you can't see it because it disappears as soon as you get the answer.
Yeah,
I get it now. I get it. Yeah. Okay.
Okay, you guys, it's past 8, and I'm so sorry, but I do have to go. But I hope this was helpful.
This was great. Thank you.
Thank you so much.
Thank you so much.
If you need another one, just send an email, and then I'll see which day works. Okay.
All righty.
Thank you so much.
Thank you very much.
Good to see you again, Steve. I haven't seen you in a long time.
Yeah, I've been away. I'm also away right now. We are all over the place with this emergency.
Wow. Okay, I gotta go. I gotta run. But good to see you all.
Thank you. Bye.
Bye. And